Good morning. Hello. Whew. Wow, done with chapter 5, thank goodness. Hopefully the quiz went well for you yesterday. We'll be catching up on some grading over this 4-day weekend break. And by break, I mean not a break for me at all, because teachers still have to do things like meetings and stuff like that. But you guys get 4 days off, Friday and Monday, which is amazing. So congratulations, you've worked very hard with online stuff, and now's your chance to take a break. And if you are thinking, but I haven't worked that hard, I'm still missing like 5 assignments in this class and a quiz, then maybe use this 4-day break as a chance to catch up. So catch up, take some time, make sure that you're where you need to be in your classes, because you will not get any new homework from your teachers on Friday or Monday, which is nice. Okay. Today we're doing 6.1, which is solving one-step inequalities. This is one of those where I'd play bingo with you, which I'm bemoaning the fact that we are not in school. Okay. This lesson is going to be pretty quick and painless today. Only 5 examples and 5 short ones at that. I think you're going to understand it pretty fast and whip through your homework, which is good. All right. Example 1 is to graph y is less than or equal to 4 on a number line. Okay. So, number line, drawing it out. Now, normally a number line would have like a 0 in the middle, and, negative numbers on the left and positive numbers on the right, which is what we always do when we make number lines, making little tally marks and stuff like that. But frankly, with these graphs, I just don't care. I don't care that much. As far as you writing out all of your tallies and making it perfect. So here's what I need to see. I need to see a line with 2 arrows on either end. I need to see 0. And then I need to see the number that you're using on the appropriate side of 0. So if it's a negative number, the number you're using is over here. If it's a positive number, it's on the right. So this is 4. And we're going to do a filled in dot right there. And then we need to graph less than or equal to 4. Okay, so this means that the answer is less than or equal to 4. That means that anything that is equal to 4 or less than 4 is considered the answer. So we just kind of draw an arrow that way, implying that 4 is included and that anything on the left is an answer. Just like when we were doing piecewise functions, if there's an equals to in the problem, that means that it's a filled in dot. And if there's no equals to, it's an open dot. Okay. Example 2. This one is one that you're going to do to test yourself and to pause the video. Okay, so draw that picture for me. It's an open circle at 1.4 and the arrow is going to the left. And what I want you to do is I want you to write an inequality. So you're going to pause the video right now and you're going to try to write something like this. Like this one was y is less than or equal to 4. You're going to try to write something like that. So pause the video. Give it a shot. All right, I'm assuming you paused. You can use any variable you want. I'm going to use x. And then this is a left to the left. The arrow is going to the left, which means it's a less than. So maybe I should write that out. Less than or equal to, that's going to the left. And greater than or equal to is going to the right. Okay. So if we're going to the left, and see how it's open circled, it's not closed, so I know that it's less than not less than or equal to. So x is less than 1.4. Example 3. Solve x minus 10 is less than 15 and graph your answer. Okay. So you're going to solve this just like you would a normal equation, trying to get x by itself. So to get x by itself right now, I'm going to add 10 to both sides. So I get x is less than 25. And here's 0, and there's 25. Aren't you happy I'm not making you do all the tallies? And then open circle. X is less than, so it goes to the left. I remember a student once telling me that they remembered that less than goes to the left because they both start with L's. So I guess that's something you could do if you want. Okay, before we do example 4, I want to do a rule. Here's a rule that we have now. If you multiply or divide by a negative number, when you're solving, flip the sign of your inequality. For example, let's suppose we have the problem x is less than or equal to, negative 2/5 x is less than or equal to 11. All right, so right now it is negative 2/5 times x. So to get rid of that times, we're either going to have to divide by negative 2/5 or multiply by the reciprocal by flipping it upside down. And remember, it's just the reciprocal. It's not the opposite reciprocal. The opposite reciprocal is used during perpendicular lines for slopes. This is just flipping the fraction, not changing the sign of it. All right, so I'm going to multiply by negative 5/2 on both sides. So on this side, I'm going to multiply by a negative 5/2, and over here, I'm going to multiply by a negative 5/2. All right, so negative times negative is a positive. These cancel each other out. 2/5, 5/2, they're done. So on this side, I've just got an x. But then see my rule here. It says if you multiply or divide by a negative number, that's the important part, a negative number. So since this was a negative 5/2, I'm going to flip the sign now. That means it used to be a less than or equal to, and now it's a greater than or equal to. And the equal to stays with it, or the not equal to stays with it. So like if it's just a less than, it becomes a greater than, and vice versa. All right, if I'm multiplying these out, I have to multiply the fractions, top times top, bottom times bottom. So 11 times negative 5 is negative 55, and 2 times 1 is 2. Negative 55 divided by 2 is x is greater than, let's see, 55 divided by 2 is negative 27 and a half. And then I'm going to put it on a number line really quick because I can. Here's 0. This is about negative 27 and a half. Exactly, that's exactly where that should go. And it's a greater than or equal to this time. So the equals to means that I'm going to fill it in. And the greater than part means I'm going to draw the arrow going to the right. All right, one more to go. Okay, example 5, last one, and this one you're going to try by yourself. Solve for x and put it on a number line. So the equation is 9y plus 3 is greater than or equal to 10y. And I'm going to put the same equation over here. And the reason why I'm doing that is because I'm going to solve it in two different ways, because I can imagine two different ways that you might solve it. So pause the video right now. Go ahead and try it out. Put it on a number line. Remember to get the variables on the same side. Oh, that's funny though. I said solve for x and there's only y's in the problem, so I guess solve for y, huh? Alright, I'm going to assume you've done it at this point. So there are two ways you can do this. One way is to get the y's on the right, and one way is to get y's on the left. So I'm going to get y's on the right first. So now I've got 3 is greater than or equal to 10y minus